energy generating stations, consuming either fossil fuels or potential energy of water. The Second World War ended in 1945 with the invention and use of nuclear energy. So, simple wording, energy is the ability to do work. What is the what is energy importance? Energy is a very important for our life. Every action we take from breathing and thinking to running and jumping require energy. We get this energy from the food we eat, which our bodies convert into usable forms. Everything we use in daily life, energy in some way, light bulbs, heaters, air conditioners, etc. Factories, machines, and vehicles are require energy to operate. This energy allow us to manufacture goods, travel a long distances, and keep our economies running. The infrastructure of our modern world depends on a reliable and constant supply of energy. Hospitals rely on energy for life-saving equipment, communication system need energy to transmit information, and even entertainment like TV and movies requires energy to power the devices we use. Okay. The second is energy sources. In the previous lectures, we have already discussed the energy sources. We discussed two energy sources, renewable energy sources and non-renewable energy sources. Okay, so first is, what is renewable energy sources? These sources are naturally replenished on a human timescale. We can use them continuously without significantly depleting them. For example, solar, wind, hydro, geothermal, and biomass are examples of renewable energy sources. And second is non-renewable energy sources. These resources are finite and take millions of years to form naturally. Their use depletes them over time. For example, fossil fuel, coal, oil, natural gas, and nuclear energy. So, what is the examples of renewable energy sources? Solar energy, wind energy, hydropower, geothermal energy, biomass energy, other renewables. First, renewable energy, solar energy. Solar energy captured from sunlight using solar panels and converting into electricity or heat. Wind energy, harvested from moving air using wind turbines to generate electricity. Hydropower, the energy of moving water, like in rivers or waterfalls, used to generate electricity through dams. Geothermal energy, heat from the earth, coal used to generate electricity or heat buildings. Biomass energy, organic materials like wood, plants, and animals, waste used to produce electricity or heat. Other renewables occur in waves, tides, and even concentrated sunlight can also be used to generate electricity. These are examples of renewable energy sources. Okay. So next, non-renewable energy sources examples are fossil fuels, nuclear fuel. Fossil fuels also constitute into coal, oil, and natural gas. Okay, fossil fuels are formed from the buried remains of ancient organisms that decomposed and transformed under heat and pressure over millions of years. Nuclear fuel, uranium, is a naturally occurring radioactive element mined from the earth. What what is environment impacts due to non-renewable energy sources? We know that burning fossil fuels is a major contributor to climate change. They release greenhouse house gases, particularly carbon dioxide, which trap heat in the atmosphere, leading to global warming. Extraction and processing of these resources can lead to air and water pollution. For example, if we see fossil fuels also constitute into coal, oil, and natural gas. If we see that coal then used in power plants to generate electricity, burning coal release significant greenhouse gases and pollutants. If we see that oil then refined into gasoline, diesel, and other fuels used for transportation and heating. Burning oil also releases pollutants and contributes to climate change. If we see that natural gas, then a cleaner burning fossil fuel used for electricity generation and heating. It still emits greenhouse gases. And if we see that nuclear energy uses nuclear fuel, the separate of atoms to generate electricity, while it does not produce greenhouse gases during operation. Concerns surround radioactive waste disposal and risk of accidents. So, these impacts create due to non-renewable energy sources. Okay. So now we see that energy sources technologies. Energy sources provide the raw materials, but we need technologies to convert them into usable form like electricity, heat, or fuel. Following the technologies. So first technology is solar panels. Solar panel converting sunlight into electricity. Solar panel use photovoltaic cell made of materials like silicon. When sunlight strikes these cells, it creates an electric current. Okay. So with the help of diagram, we understand the working process of solar panels. So first we see that the components of solar panel and then we understand the working process of solar panel. First the components is we see sunlight represent by wave arrows, sunlight strike the solar cell. Next we see anti-reflective coating. This is a thin layer on the top surface of the cell that helps minimize reflection and allows more sunlight to enter the cell. And second, silicon layer, the core of the cell made from silicon, a semiconductor material. And next is p-type layer. This layer has a positive electrical charge due to missing electron in its atomic structure. N-type layer, this layer has a negative electrical charge due to extra electrons. Electric field, the p injection creates an electric field within the silicon layer. These are metal content on the top and bottom of the cell that collect the generated electricity. And now we see how solar panel work. First, sunlight photons enter the cell and strike the silicon. The photons knock electrons loose from their atoms in the silicon, creating electron hole pairs. Okay, create hole pairs. The electric field within the cell pushes the free electrons towards the n-type layer and holes toward the p-type layer. This movement of electrons and holes create an electric current that flow through the cell when a circuit is connected to the electrical contacts. The collected electricity can then be used to power devices or feed into the power grid. What is the importance of efficiency into the solar cell? The efficiency of a solar cell depends on various factors, including the quality of the silicon and the design of the cell. Multiple solar cells are connected together in series and parallel to form a solar panel, okay, which generate more electricity. Solar panels are a clean way to generate electricity, but their initial installation cost can be higher compared to traditional energy source. Okay, so next energy sources technology is wind turbine. Wind turbine basically converting wind energy into electricity. Wind turbines have large blades. They rotate in the wind. The turning blades drive a shaft connected to a generator, which produce electricity. Okay, we see that this diagram. This is a wind power. Now we understand the working process of wind power, and first we also understand the R components present into the wind turbine. First, we see the tower. This is a tall vertical structure that supports the entire wind turbine. It's made of steel to withstand strong winds. Second, Nestle. This is a housing at the top of the tower that contains the key components for generating electricity. It can rotate to face the wind for optimal efficiency. And third is router. This is a assembly of blades that captures the wind energy. The blades are typically made of fiberglass or composite material for strength and lightness. Next is blades. These are very large airfoil shaped structure. They spin in the wind. Wind passes over the blades. It creates lift, causing them to rotate. The number of blades on a turbine can vary. Typically range from two to three. And next is drive shaft. This long shaft connects the rotor to generate within the Nestle. The rotation of the blades transfer kinetic energy through the drive shaft. Gearbox. The gearbox increases the rotational speed of the drive shaft before it reaches that generator. This is because the wind turbine blades spin at a slower rate, while the generator requires a higher speed to efficiently produce electricity. Generator. This is the heart of the electricity generation process. The rotating drive shaft from the gearbox spins the generator shaft, which converts the mechanical energy into electrical energy through the principle of electromagnetism. Anemometer. This is a device mounted on the nacelle that measures wind speed and direction. This information is for the turbine to adjust its position to face the wind directly and maximize energy capture. Electrical cables. These cables carry the generated electricity from the generator down the tower to a transformer. The transformer increases the voltage of the electricity generated by the turbine. This is necessary for the efficient transmission of electricity over long distances to the power grid. Okay, this is a network of the interconnected transmission line that distribute electricity to homes, businesses, and industries. This is our components of wind power. In the previous session, we already discussed our components, but I revise. Okay, what is a working process of wind power, wind capture, wind blow across the large blades of the rotor. The blades are designed like airplane wings. Wind passes over them. It creates causing the blades to rotate. The faster the wind speed, the more energy is generated, and the faster the blades spin. The rotation of the blades creates kinetic energy. The rotating blades are connected to the drive shaft. They transfers the kinetic energy down the tower. The gearbox increases the rotational speed of the drive shaft. Wind turbines spin at the slower rate, while the generator needs a higher speed to produce electricity efficiency. High speed drive shaft from the gearbox spin the shaft of the generator within the nacelle. The generator uses the principle of electromagnetism to convert the mechanical energy of the rotating shaft into the electrical energy. The anemometer mounted on the nacelle measures wind speed and direction. Based on this data, the nest can rotate to face to the wind directly, ensuring optimal energy capture. The generated electricity, okay, travels two cables down the tower to a transformer. The transformer increases the voltage of the electricity for the efficient transmission over long distances. The high voltage electricity from the transformer is fed into the power grid for distribution to homes, businesses, and industries. Okay, this is the working process of wind power plant. And additional notes, uh, what is the efficiency of wind power? Uh, Please off the mic. Wind turbines operate most efficient within a certain wind speed range. Very low wind speed, they may not generate enough electricity to overcome operational cost. Wind farms consist of multiple wind turbines separate out over a large area to maximize wind capture and electricity generation. Wind energy is a clean and renewable energy source with minimal environmental impact during operation. Okay. The second energy sources technology is hydroelectric dam, converting water energy into electricity. Dam are create a reservoir of water at a higher elevation. Flowing water from the reservoir spins turbines connected to generators producing electricity. Please off the mic. Disturb the lecture. So with the help of this video, we understand the working process of hydroelectric power plant, and we understand we uh, how with the help of hydroelectric power plant we generate electricity. Mr. Khalil, please off the mic. Mr. Khalil, please off the mic.
सब्जी सब्जी कोई भी नहीं ना लिया खाने का लेकिन यहाँ
Mr. Khalil, off the mic because your voice disturb our lecture.
के साथ रियाल का है मैंने आपसे कहा है मैंने आपसे कहा है मैंने आपसे कहा है कि सर ब्यूटी कॉर्नर पे चले आपने
मैम आप इनको डिस्कनेक्ट कर दें, ये तो कोई और ही ड्रामा चल रहा है।
Yes. Okay.
सही खड़ा है बोला काली कौन देखे
Okay,
वापस
we will. Um, Mr. Khalil, please off the mic. Okay, now we see the video. With the help of this video, we understand the working process of hydropower plant. So please understand this video.
मेरी नाल क्लास चलती पई है नाल
केड़ी
सोलर एनर्जी दी क्लास सोलर इंजन
खलील भाई अपना माइक ऑफ करें।
Okay, in this video, we say that the turbine is connected to an electromagnetic generator which produce electricity.
क्या चल
Hy- uh,
लग गई है
hydro, with the help of them, we generate electricity. Rise the
दूध
please clearly this video and understand how hydroelectric power work.
बेटा मैं क्या तेन दुध दे रही हूं मैं कदों इनकार किया सोने बेल्ट ला के दुध पियाना
Okay, turbine generate electricity when water fall into the turbine. Then, with the help of high pressure, generate blades of the turbine and produce electricity.
चल
पैर से छह आवाज तो नहीं होनी पड़ी
Benefits cost. This cost is no higher than the other resources. We can control easily. Water supply we provide. When we create the larger dam, then more effects created. This technology is free from carbon dioxide emission. Okay, with when we use this technology, so no any emission into our environment. So this is the working process of hydroelectric power plants. Okay, so next technology is geothermal power plant, converting heat from earth core in electricity. Technology geothermal power plant utilize hot water or steam from the earth core to drive turbines and generate electricity. Three types of geothermal power plant. Number one, dry steam plant. Number two, flash cycle steam plant. Number three, binary cycle plant. There are three types of geothermal power plant. We discussed all types of geothermal power plant one by one. Okay, so first is dry steam plant. This plant use dry steam that is naturally produced in the ground. This steam travels from the production well to surface and through a turbine, and after transferring its energy to the turbine, it condenses and is injected back into the earth. This type are the oldest type of geothermal power plant. The first one was built back in 1904 in Italy. Because this type of a power plant requires the highest temperature, they can only be used where the temperature underground is quite high, but this type require the least fluid flow. The second type is flash cycle steam plant. These type are the most common due to the lack of naturally occurring high quality steam. In this method, water must be over 180 Celsius and under its own pressure, it flow upwards to the well. This is the lower temperature than dry steam plants have. As its pressure decreases, some of the water flashes to steam, which is passed the turbine section. The remaining water that did not become steam is cycled back down into the well and can also be used for heating purposes. The cost of these systems is increased due to more complex parts. However, they can still compete with conventional power sources. Okay. The third type is binary cycle plant. Binary power plants are expected to be the most commonly used type of geothermal power plant in the future. Locations outside of the known hotspots began to use geothermal energy. This is because binary cycle plant can make use of lower temperature water than the other two types of plant. They use a secondary loop which contains a fluid with a low boiling point such as pentane or butane. The water from the well flow a heat exchanger which transfers its heat to this fluid, which vaporize due to its lower boiling point. It is then passed a turbine. The same task is steam. There are three types of geothermal power plants. Okay. Now, the next technology is biofuel production facilities. Okay, converting organic materials into the fuel. These facilities convert organic materials like plants, wood waste, or animal waste into biofuel like ethanol or biodiesel. Okay, this is a technology of biofuel production facilities. Okay, with the help of diagram, we understand the working process of biofuel technology. In this diagram, we see the first feedstock preparation. Corn are crushed into a fine meal using a grinder. This increases the surface area of the material, making it is easier for enzyme to break down the stretches later in the process. Next is enzymatic breakdown. Water and enzymes are added to the crushed corn. These enzymes act as biological catalyst, breaking down the complex stretches into the corn into simple sugars. Sugar mean sugar. These are sugars. Fermentation. Yeast is introduced to the sugar mixture. Okay, the sugar mixture we get in a large fermentation tank. The yeast feed on the sugars are produce ethanol and carbon dioxide through a process called fermentation. This stage typically takes several days. Okay. Then next is distillation column. Okay. Distillation column. This is a distillation column. The fermented mixture now containing ethanol, water, and other components is heated in a distillation tower. Ethanol has a lower boiling point than the water. Okay, ethanol boiling point is lower than the water, so it evaporates first. Okay, first ethanol evaporate, then evaporate the water, and is collected. This process purifies and concentrates the ethanol into a usable fuel. The last is drying and blending. Okay, this is a drying and blending. This distilled ethanol may contain some water, okay, and depending on the final use, it might undergo further drying processes. This produced ethanol is often blended with gasoline to create a biofuel blend like 10% ethanol and 90% gasoline used in many cars. Okay, so we also discussed what is benefits of biofuels. Renewable sources reduce emission. Renewable sources biofuel are derived from organic materials. Are renewable resources compared to finite fossil fuels. Okay, reduce emission mean biofuel can potentially reduce greenhouse gas emission compared to traditional gasoline, especially if this is a clean. What challenges we face when we use biofuel? Because here more benefits is present and challenges we also face when we use the biofuel. So what challenges is large scale biofuel production can compete with food crops from land use, rising food security concerns. Converting land for biofuel crops can lead the deforestation and habitat loss in some cases. The energy used to grow, process, and transport biofuels need to be considered to ensure a net energy gain. Okay, so we take a example and understand in simple wording uh, of biofuel. Okay, for example, ethanol from corn. Ethanol, we know that ethanol is the most common biofuel, okay? Produce ethanol in the United States. Corn is a widely ground crop used as the primary feedstock for ethanol production. The sustainability of coal-based ethanol is due to the potential for land use change and competition with food production. Okay, so now we discuss the working process of biofuels, and then we discuss what is benefits and also discuss challenges. Okay, now we will meet again after 10-minute break. Okay, after almost 10 minute break, we meet again and we start the next technology. Our next technology is nuclear power plant. Nuclear power plant converting nuclear fuel into electricity mention safety measures. Technology. Nuclear power plant use control nuclear fuel, the separate atoms to generate heat. This heat is used to create steam that drives turbine and produce electricity. If we see the safety measures, then nuclear power plant have multiple safety features to prevent accidents and radiation leaks. These include contaminant buildings, emergency cooling system. For example, nuclear power plant provide a significant portion of electricity generation in some countries, but concern remain about radioactive waste disposal and the risk of accident. And the next technology is energy storage solutions. Energy storage solution means storing energy for later use. But this technology, energy storage solution, allow us to store excess energy generated from renewable sources like solar and wind. Okay, when we install the solar our homes, then we also use the batteries because we want to store the energy. Okay, for night time and wind for use when these sources are not available. Examples, batteries. Okay, uh, batteries we also use for storage the energy. Large scale battery system can store electrical energy for later use. Okay, we use a battery because we want energy later when we need. Pump hydro storage. Electricity is used to pump water uphill to reservoir. When needed, the water flow back down to turbines to generate electricity. Okay, pump hydro storage we use because this push the downward water into upward, and then we use this process, this technology, we generate the electricity. Okay, because we discuss battery and PEM, but in this diagram we only discuss the battery. So in this diagram we understand the working process of battery. Okay, so in the diagram we see that AC, okay, input output. AC mean alternative current, electricity from the power grid. Okay, this is a one second. This is a power grid. Enters the system for charging or exists during discharge. Okay, and the next is converter. Okay, next is converter. AC-DC converter mean convert AC electricity to direct current. For charging the battery, it also converts DC electricity from the battery back to AC for use on the power grid. Okay, and then is battery management system. This is okay. You see that this is battery. B mean battery, M mean management, and S mean system. This is component monitors the battery health, temperature, and charge discharge cycles, ensuring safe and efficient operation. Okay. And then next is battery. You see that? Yeah. This is a battery system. This consists of numerous battery modules connected together to achieve the desired storage capacity and power out. Uh, For example, if we take the example of batteries, so large-scale battery storage facilities are being developed in many regions. These facilities can store excess solar or wind energy during the day and discharge it in the evening when uh, demand peaks. Okay. The important things for this storage, choosing the live storage solution. Okay. Storage capacity and duration, the amount of energy that needs to be stored and for how long. Response time, how quickly the stored energy can be discharged, okay, to meet peak demand. Efficiency means the amount of energy lost during charging and discharging cycles. Cost, okay. The important is cost, the initial installation and maintenance cost of the storage system. So this is the simple working process of battery. Okay, the last is consumer mean we use the energy. Okay, our last slide is what is the future of the energy? What is the future of energy? Very, very important question. Energy storage solutions are essential for overcoming the renewable sources like solar and wind. Okay, smart grid will play a vital role in uh, manage the complex energy landscape of the future. Hydrogen power has the potential to revolutionize transportations, while advancement in fuel energy could one day provide a near limitless source of clean energy. By this advancement and for fostering continued innovation, we can build a more sustainable and secure energy future for generations. Okay, I hope this slide provided a good overview of energy sources and technologies and exciting future ahead. Okay, so this is today we cover the energy sources and technologies. Any question? Any question? Okay, any question? Okay, no. The session is ended. Okay, the session is ended. We again meet in next session next Friday. Okay. Okay. Bye.
Inshallah. Thank you.
Okay.